Welcome to BIM 200 Extended, Evaluating and Using BIM Project Execution Plans. In this video, we will discuss the purpose of the BIM Project Execution Plan, or BIM PxP, and how to evaluate the BIM PxPs for compliance with MHS BIM minimum requirements. We begin with an overview of BIM capabilities and attributes and describe how effective monitoring of the BIM PxP will help MHS achieve its business goals. In order to understand the components, organization, and value of the BIM PxP, it is useful to understand the capabilities and attributes of BIM that are most important to MHS. Specification of BIM processes is the core of the BIM PxP. MHS is one of many government agencies that require new projects to be developed using BIM technology. BIM has been widely accepted by designers and builders because it allows each organization to work more efficiently, both individually and collectively. MHS has developed BIM objectives that are directed at achieving agency goals more effectively through the use of BIM technology. Most of these goals concern better data management. The UFC BIM chapter describes these objectives and their relation to the MHS BIM minimum requirements. The MHS BIM minimum requirements provide explicit instructions regarding usage of BIM on the project and will guide PxP development. In this video, the MHS BIM minimum requirements will be abbreviated as BMR. BIM is different than CAD because BIM is composed of 3D objects that are associated with intelligent data. This is the core of BIM's value, the ability to achieve enhanced visualization through 3D representations of building components and to serve as a conduit of data. Enhanced visualization is easy to appreciate. It can take years of training to understand a two-dimensional drawing of a complex HVAC system, but the 3D model can be quickly evaluated. Enhanced visualization permits more effective communication, troubleshooting, and understanding of system components and their relationship by the entire project team. The benefit of BIM as a data repository or data coordination tool is the attribute that allows BIM data to be used and shared by many stakeholders. BIM objects, like the ductwork shown here, have associated property tables that are part of the native software. BIM affiliates data with all components in the model. This data includes standard attributes, or properties, as well as custom parameters encoded in the model. This information, both the default properties and custom parameters, can be displayed in a schedule view within the BIM application. The schedules and associated data can be exported from a BIM application in several ways, including spreadsheet formats. MHS is a data-driven organization. Each phase of the project generates new information, including the operations and maintenance phase. An important MHS goal is the integration of the data produced by many firms over many years to create a single version of the truth for facility information. MHS BIM objectives describe a method for exchanging data between lifecycle phases. MHS developed consistent data standards and utilizes those to develop project programs. This data will be developed in the project BIM and at final delivery be transferred back to MHS for use in its continued facility management operations. Rooms can also be considered as objects and are a key component of BIM. Like any other object in BIM, room objects have data fields associated with them, such as room name or finishes, as well as properties such as area, volume, and height. MHS has a standard list of room-level parameters that should be attached to room objects in the project BIM. Room object data can be exported from a BIM-derived schedule. BIM room data is also important for the Program for Design, or PFD, validation check, and other reports that will be discussed later. Furniture and equipment objects also have associated data. For instance, a treatment bed can have data such as joint service number, room ID, and manufacturer attached to each instance of the object in the model. MHS BIMs are required to contain many components, such as doors, air handlers, and electrical panels. These components are affiliated with BIM room objects through the Project Room ID field. Because BIM objects are linked with data, BIM allows designers to analyze and even predict the behavior of the building by testing the model. This is sometimes called virtual testing. The testing and analysis process is an important factor in quality control for both the project team and the government. Two BIM-related processes of specific interest to MHS are SEPS and COBE. SEPS, or the Space and Equipment Planning System, is a database software system that develops the project program and delineates the rooms and equipment requirements for each project. There are BIM programs available that automate the creation, placement, and validation of SEPS objects in BIMs and assign data to those components. These programs are the topic of BIM 500 Extended, SEPS BIM Tools. In the BIM process, information generated by one group can be easily retrieved, evaluated, or used by another group. Programming information developed by MHS can be read into the model as it develops, allowing designers to understand and validate the program for design. Also, SEPS components can be automatically generated from the program and located in the correct rooms. As the project proceeds, design data transferred to the builder. Information developed during construction, such as manufacturer's specifications, is ultimately provided to the owner-operator for their operations and maintenance personnel. The goal of MHS is to achieve consistent data development from initial project programming through facilities management. The ultimate workflow will take project programming data for space and equipment that has been developed in SEPS into the BIM model, where it is developed and reviewed as the project progresses. At project delivery, the as-built BIM, replete with SEPS data for building components, is delivered by the project team to MHS. Building information model is not merely one software application, but is a body of information, generally developed by using many applications. This is a summary of the process MHS envisions for SEPS and BIM. SEPS project planning data, in the form of a spreadsheet, is integrated into components within the BIM model. During project development, the model and its data are verified to ensure that the equipment and rooms in the model align with the program. The government can verify this by reviewing files or reports exported from the BIM model. Once construction is complete, information about the equipment will be exported to allow import into facilities management software. COBie is a data exchange format that MHS requires for SEPS objects, as well as built-in objects like air handlers and pumps that are referred to as Real Property Installed Equipment, or RIPE objects. There are BIM software tools that automate the aggregation and export of COBie data. MHS employs COBie to format and export component data from the project model. COBie data exchanges are necessary to produce some of the deliverables required by MHS. COBie is the topic of BIM 400 Extended, COBie BIM Tools. Another important concept is Level of Detail, or LOD. This refers to the completeness of BIM data. The MHS BIM minimum requirements specify the minimum LOD required for project models. At the concept stage, LOD 100 objects may be quite generic. After LOD 300, it is common to supplement the BIM model data with data in other formats from consultants, subcontractors, fabricators, or manufacturers. The total body of information, at LOD 500, is delivered at project turnover to the owner-operator. The BIM PxP is the government's tool for verifying that MHS BIM requirements are satisfied. BIM is an evolving technology, and the methods for its deployment and implementation vary between firms. The BIM PxP allows the entire team to understand the strategic BIM goals for the project, their roles and responsibilities, and to plan their work process. This reduces the overall risk to the project because execution processes and deadlines are defined at the beginning of the project, as are the resources necessary for the effort. It is a way to measure progress throughout the project. Through the PxP, project team members can synchronize their efforts to meet MHS BIM objectives. On most project teams, different team members have different competencies and priorities. The PxP is a tool to optimize project team collaboration and a tool to facilitate the review and validation of the BIM effort by the government. The BIM PxP should be developed in the early stages of a project and continually refined as additional participants are added to the team. It is developed as a collaborative effort by the project team, with a BIM leader responsible for coordination. The BIM leader is typically the designer or builder. The BIM PxP is reviewed and approved by the government at the beginning of a project. It will guide the BIM process for the project team and serve as a schedule of BIM activities for the government. MHS does not have a standard format for the BIM PxP, but does have requirements for the project execution plan detailed in the BIM Minimum Requirements Guidance document. Additional guidance for developing a PxP can be found in the Building Smart Alliance Project Execution Planning Guide, which evolved from the work originally done at Penn State University. The template can be found on the web at the link shown on the slide. This link is also provided within the BMR. Once the BIM PxP is approved, the government uses it to monitor progress throughout the project. The government consults the approved plan to validate compliance, conduct reviews, and verify that deliverables are submitted in a complete and timely fashion. A successful BIM project will provide information that is useful during the full building life cycle. Other benefits of working with BIM are that the model provides decision support to quickly evaluate options, the documents have fewer gaps and errors, and the project proceeds with less rework. Let's discuss the components of the BIM PxP and identify how the PxP helps communication between the AEC team and the government. The BIM PxP will define how the project team collaborates on model development and data management during the design and construction process. Traditional methods of planning and scheduling utilize bar charts or CPM schedule or work breakdown structures. These tools may not capture the spatial links and dependencies between activities. A well-defined PxP fosters an environment of shared vision and shared responsibility. BIM and the PxP foster collaboration, and a large component of successful collaboration is good team communication. This is not something that can be accomplished with technology alone. The Association of General Contractors BIM Education Program states that implementing BIM is considered to be 10% technology and 90% sociology. The BIM PxP contains information that can generally be grouped into 6 categories. These categories are descriptive only, and some BIM processes might be included in more than one category. For the purpose of discussion, the categories include BIM project information and goals, which describes how the team anticipates using the model, the analytic functions that will be employed, team roster, team assignments, and basic project information. BIM content, the components, data, formats, and measurement systems used for the project. Technologies, software applications used for design, structural analysis, cost estimating, design reviews, energy analysis, or other major support functions for the project. Technology descriptions should include the hardware requirements and collaboration methods that are anticipated for use on the project. Project timeline. The BIM PxP defines when project milestones occur, the submittals that are required, their sequence, the final deliverables for the project, and the quality control and review processes that will be performed during project development. In every case, the government should be able to validate BIM data without using the native BIM software. Required data can be exported in formats readily available to the government, such as spreadsheets, PDF files, or CAD files. The MHS requires that specific project data fields be incorporated in the model as project parameters. This data will eventually be delivered to MHS with the as-built model and will provide basic project data that can be analyzed and compared with other MHS projects and support the MHS full lifecycle management efforts. Some parameters are not resident in a standard model, but must be encoded by the project team. The BIM PxP document will contain basic information about the project and will list key project contacts and the staffing and roles of the project team. The PxP should clearly describe the value of BIM for the project by defining the overall goals for BIM implementation. BIM goal and process information helps each firm understand their specific responsibilities for creating BIM data. The PxP also delineates the multiple uses that BIM will have on the project. Once BIM uses are established, process mapping can be used to describe in more detail the sequencing and interaction between the primary BIM uses on a project. Process mapping is a tool that is encouraged but not required as part of the BIM PxP. The PxP also will specify information exchanges that occur between the project participants. The collaboration or meetings that will occur during project development should also be itemized in the PxP. BIM content is described and assigned in the BIM PxP. Each team member knows which components are required from other team members across multiple disciplines. The MHS BIM minimum requirements describe the objects and level of detail that should be included in the integrated project model or models. The BIM PxP will contain a description of the data contained within BIM and its format. This may be done in several different ways, from a high-level description of the content to a detailed matrix, listing component content such as floors, ceilings, doors, furniture, and many other objects. These descriptions will indicate the disciplines contributing to the model, such as architectural, mechanical, civil, and others. Data attributes affiliated with model components are of special interest to MHS. The MHS BIM minimum requirements list the mandatory data fields in the appendices. These include project level parameters, room level parameters, object level parameters such as Real Property Installed Equipment Parameters or RIPE, and medical equipment and furniture parameters. It is possible that several different team members may edit or update a particular parameter during the course of the project. Therefore, BIM PxP should also list team members that have the responsibility for creating, populating, and verifying the BIM parameter data. The PxP must describe the level of detail, or LOD, that will be delivered at each project milestone for each coordinated design system. The models may vary in level of detail for individual elements, but must include the features described in the BIM Minimum Requirements document. Many commercial software applications may be used by the project team at different points of project development for many functions, such as design, analysis, construction management, model review and validation, and project collaboration. The BIM PxP should itemize the software applications used throughout the BIM development process. Any software that conforms to MHS requirements and is acceptable to the entire team may be used. The government's evaluation and use of the BIM PxP is critical to the success of the project. MHS BIM minimum requirements provide a general framework for scheduling BIM submittals and reviewing the progress of BIM. It is the government's responsibility to revisit the BIM plan periodically and verify that the plan is being implemented. The BIM PxP is a living document and should be periodically updated and reviewed as the project progresses. The BIM workflow for an MHS project begins with the project team reviewing MHS BIM requirements and defining how the project team will meet those requirements. The team then identifies and lists the processes that are part of an ongoing periodic review. The BIM PxP identifies submittals and data requirements and defines the format for the submittals. MHS minimum BIM standards serve as a guide for required BIM submittals that must be itemized in the BIM PxP. These submittals include schedules, reports, and verification of model compliance with MHS requirements. MHS minimum BIM standards require submittals in technology formats that are well known and accessible, such as Excel spreadsheets. The BIM PxP identifies the inputs and output for BIM and the format and data exchange used to accomplish these goals. A detailed table describing the required project BIM submittals can be found in the appendix of the MHS BIM Minimum Requirements document. The BIM PxP should address the stakeholders and processes responsible for providing these submittals. The MHS BIM Minimum Requirements describe the submittals and reviews to be made during the course of the project, including interim design submittals, the final design submission, and the final as-built deliverable. Each of these stages requires a contractor-certified written report confirming that consistency checks have been completed, along with model, facility data, workspace, and CAD data files in native formats, and a 3D interactive review format of the model. Over-the-shoulder progress reviews will be conducted periodically to review the implementation and use of the model, including interference management and design change tracking information. Interim submittals should demonstrate progress toward project completion. Every element of a project does not need to be included in the model. It is important only to define the model components that are necessary to support each BIM use. BIM submittals should have the required parameters created even if the data to populate them is not yet available. The SEPS BIM export room data should be incorporated into the model no later than the first design submittal. The final deliverables are provided at the conclusion of the project. These deliverables are the culmination of creating BIM annotated with robust project, room, and object data. They are used to facilitate the flow and exchange of data to systems and processes in subsequent phases of the building lifecycle. Quality control is a critical function for the BIM team. It is important for the team to use the same conventions to avoid inadvertently creating errors or causing the model data to become corrupt. MHS supports the use of the U.S. National CAD standard to guide the formatting of drawings output from project models. During project development, the team will continuously be checking the model to ensure that no undefined, incorrectly defined, or duplicated elements exist in the BIM. The project team will have the primary responsibility for conducting these reviews. Quality control of the BIM is the responsibility of the contractor. Members of the project team may choose to use a commercial software tool to help automate these ongoing checking routines. Design and construction reviews will include the traditional visual checks of project drawings to ensure the design intent has been followed and that there are no unintended elements in the model. Some of the required quality control measures are forms of analysis and include an interference check. Interference checking, or spatial coordination, identifies conflicts in location between different building components. In this process, design and shop drawing models are combined into one consolidated model, and the BIM software generates a report of all the conflicts it finds. Resolving constructability issues before construction saves costly demolition and rework. Results from interference analyses can be reviewed in the model as well as reviewed in a clash report. MHS minimum BIM standards require that BIM design tools are capable of exporting data in an IFC, or Industry Foundation Class, format, which is one type of open data format. During project development, it is critical that the project team align the design with the program's total area requirements. Gross area tabulations should be calculated using the BIM application's automatic calculation attributes in accordance with the UFC's gross square footage calculation guidance. Gross area and departmental gross area tabulations are required deliverables at all project submittal stages. Net area tabulations must be calculated using the BIM's automatic net area features and shall be in accordance with the UFC. The PFD validation check provides a report of the project BIM rooms and compares it to the project program plan. The comparison can either be done within the model platform or via an external project review program approved by the government. Actual net square feet for the design shall be automatically generated within the model and not manually entered. The rooms that fall outside of an allowable variance that has been established for the project will be indicated in the report. The PRC validation check will provide a report that compares the approved PRC list by room to the actual design PRC contained in the project BIM. The comparison shall either be done within the model platform itself or an external project review program approved by the government. The report shall provide a list of rooms where the design PRC does not match the approved PRC and the specific items that do not match. The non-matching items list shall include at a minimum the PRC equipment item approved and expected and the designed PRC item not matching. As part of its mission to develop world-class facilities, the MHS believes BIM is an essential tool. BIM will support efficiencies during and beyond the project lifecycle and allow MHS more visibility into the materials and components that are used in each facility. In conclusion, BIM PxP evaluation and use should be considered an evolving task that is maturing within the practice over time and improves with each new project. BIM allows the MHS, design and construction agents, and associated project designers and builders and other contractors associated with the project execution to work smarter, not harder. Rather than trying to manage many documents developed independently by multiple consultants, BIM is an integrated model that reflects the accumulated contributions of the project team. The data requirements and reports described by the MHS minimum BIM requirements are, for the most part, requirements that have existed for over 15 years. The use of BIM allows the data to be retrieved more readily and analysis to be conducted more quickly and thoroughly. Most importantly, the MHS understands that the adoption of new tools can sometimes cause confusion. We encourage government personnel to submit inquiries concerning the BIM PxP to the point of contact listed in the BIM minimum requirements. We hope this video helps explain the value of BIM and the BIM Execution Plan. For additional information, please visit the MHS World Class Facilities website at the link shown on this slide.